All right, so in this lesson, we're going to look at some more just solving algebraic equations, and we're going to look at some of the physics equations that we're going to need to use this in. So this lesson is going to be a bit of a review of the last one, plus we're going to add in a little bit new stuff, and I really want to look at the questions that typically people forget how to do, and the ones that cause problems later on when we get using the algebra more. So that's going to be especially during our next semester. So I'm going to start with a couple of easy questions. Now, these are questions that you've really seen before when we did ratios, but I want to look at them in a slightly different way because I think it may make them a little easier for you. So this question is the easiest one of them all. So if you remember, when we're solving an algebraic equation, we want to undo the math. So in this question, we have x divided by 17.4. So if it's x divided by 17.4 and I want to solve for x, we're going to have to multiply by 17.4. Whatever you do to one side, we do to the other. We need to keep things balanced. Multiplying both sides by 17.4, they cancel out on the fraction side. So we've undone the math there. 17.4 on the top, 17.4 at the bottom creates an equivalent to 1. So that's why we can cancel them out. And we have x is equal to 0.6504 or 6,504 10,000ths times 17 and 4/10 leaves us with x equals 11.32 or 11 and 32 hundredths. Now I haven't told you where to round to here. I would argue you could do 1 or 2 decimal places. So we have 1 decimal place here. We have 3 digits that are not zeros. In this question, we have 4 digits. This 0 we're going to count because it's in between a 5 and a 4. It's in between 2 numbers. So we have 4 digits here, 3 digits here. So we could keep 3 or 4, and our answer sig figs would say we should really only keep 3. But I don't enforce the sig fig rules. Logical rounding would say, 1 or 2 decimal places would be enough. To keep 4 decimal places, there's a little bit of overkill just based on how many are here. Okay, so I just kind of look at how many digits and use that to count. That often helps. All right, now let's look at the next question. The next question is the type of question that people make mistakes on a regular basis. So this is one of the ones I want you to pay attention to because our next section uses trig. And when we do trig, we're going to see both of these types of questions. So we have an x. On this case, x is on the bottom. When x is on the bottom, that is the same as 1 over x times 42.5 equals 13. We could write it that way. So this 1 over x is what causes us the trouble. We want to find out what is x, not what is 1 over x. So a lot of times when people do this question, they'll say, oh, well, it's division. Let's just multiply by 42.5. But that doesn't cancel out at 42.5 because we have 1 over x times 42.5. So there's already multiplication here. I know it looks like division, but we really kind of have a multiplication scenario happening. So what I always tell people to do is let's get rid of the fraction. It's the easiest way to start. If you have a fraction, try to eliminate it. It's easy to get rid of the fraction in this case. Multiply both sides by x. Think of this as 13 over 1. I don't like doing cross multiplying. So I'm going to erase that over 1 because I don't want it to cloud your judge, just make it confusing for you. So we're going to multiply both sides by x. This x and this x cancel out. So now we have 42.5 equals 13x. Now we're down to easy stuff. We're just like ratio questions. So if you kind of want to think back to ratios, this is one of the ways you can do these questions. So 13 times x means we have to now divide by 13, divide by 13, and we end up with x is equal to 42.5 divided by 13, which is equal to 3.27, is equal to x. So this would be our final answer. I like going back and putting boxes around them because I just find it easy to find them on the page. Just a good habit. Now, you could have done this question like a ratio, put a 1 under the 13. You would have got exactly the same answer. Solve it using cross multiplying. That would be a good way to do it. You've already learned how to do that. All right, so 42.5 over x equals 13. And first, get rid of the x. So what we're really doing is bringing the x up to the top. You'll notice x is no longer on the bottom here. Now, if we were to do this a whole lot of times, and I think I actually have some examples on the next slide. No, I don't. I eliminated the ones on the next slide. I figured you guys would get it on the first try. We'll see. If you take a look back at the beginning here, you will notice I'm just going to switch my pen color because I think it can be helpful for us. Here we have x on the bottom, and 13 is off to the side. Notice when we finish rearranging, when we come down to this step, 13 is now on the bottom and x is alone. After it's rearranged, we have a switch. Okay? To show the work, we need to show the middle steps. But the more of these that you do, especially when we get to trig, you'll find that you'll do it without even thinking. When x is on the bottom and you only have one thing over on the side here, they end up trading places. And that's due to the math. So you need to understand this middle step where we multiply both sides by x to bring x up to the top and then divide by whatever's next to x. But that's a shortcut that I will allow you to use as we go forward. Now, for any kind of test or assignment that you do for me, which you will have one at the end of this lesson, it's going to be a paper assignment. So I want you to hand in a written copy so I can see how you're doing your work. I would like to see the middle step. All right, so this is a pretty easy type of algebra, but the biggest thing to watch for is when this x is on the bottom, when the variable, it doesn't matter if it's an x, we're gonna have another example of it towards the end. When the variable is on the bottom, you need to bring it up to the top. And the way that we do that is we multiply both sides by the variable. So we'll come back to that in a few minutes. But that's the question, one of the questions that I see the most errors with. Another type of question you're going to see is a question that looks like this one. For some of you, you may recognize this format may look familiar to you. Some of you will recognize it as the equation a squared plus b squared equals c squared. So we've just adjusted the letters. This is Pythagorean theorem. So you're going to see Pythagorean theorem again next week. So it's coming up in about 1 or 2 lessons ahead. So we need to know how to solve this because we need to know how to do trigonometry. So in order to solve these questions, first of all, let's combine what we can. So we could do the math with this and make it simple. So first we're going to simplify. So if there's easy math we can do, we're basically combining like terms. Remember, we got to follow order of operations here. And by following order of operations, that means I need to do the squares first. So when I combine these two, I'm going to end up with 2.25 plus 13.69. So I've just done the squares is equal to x squared. Now that we have that, we can combine these two pieces and we get 15 and 9400 is equal to x squared. Now we're at the point where we need to solve for x. Many people will stop here. Don't stop. Okay, we're not done. So don't stop at this point. You need to keep going. Here the issue is we found out what x squared is, but we haven't found out what x is. The opposite of a square is a square root. So we're going to take the square root. So you will need to find in your calculator the square root button. For my particular calculator, I'm not very good at this on video. For my particular calculator, let's see if it goes up clear there. Right next to the squared button is the square root sign. I know it's kind of backwards, so it's a little hard to see. So what we're going to do is we're going to use our square root of 15.94. Make sure you can find your square root. If you can't find your square root, send me a message. I'll make sure you're able to figure that out in your calculator. Sometimes even just asking a classmate will help you. You will need to know this for Andy's electrical course, guaranteed. He requires it as one of the mandatory pieces. So for the wind class, you will need to know how to do Pythagorean theorem and be able to find your square root. So 15.94, take the square root of that. We get 3.99 is equal to x. Now I've rounded these off. I would probably say we could go back and we could eliminate a decimal place, eh? 15.9 or 1.5 and 3.7 probably means that we could round this to approximately, well, then this 9 is going to push this 9 up to a 10, so 4.0 equals x. So I would argue that we could, either one of these I would accept for a final answer. All right, so it's just a matter of how we round it. So a nice simple question. We're going to do the same thing over on this side. We'll simplify it, and then we'll do some rearranging, but this time we're solving for b. So 12.4, we're going to square it. So 153.76 plus b squared equals 25.4 squared will leave us with 645.16. Now I've kept all of my decimals as I'm going through, or lots of extra decimals as I'm going through, and that's going to leave us with a more precise answer. We should do that. Keep extra decimals as you're calculating, and then we'll round at the end. Now we need to get b alone. We're still looking for b alone, so we need to move this component to the other side. This is a positive 153, so we need to subtract. We've subtracted it from both sides. That's going to make this go to a 0. Now we're left with b squared is equal to, we can solve these two, 491.4. Again, don't stop. We're at b squared, we're not at b. Make sure you take your final square root. So we'll take the square root of both sides, and we find that b is equal to 22.17. Now let's look back. One decimal place everywhere. Let's round that to 22.2. Okay, so that's our final answer. And I'm just using logic here because I haven't told you where to round. I'm using some logic to identify what would be an appropriate rounding spot. Now I know Sam doesn't always behave properly with rounding, but it'll always tell you where to round. But if it's an assignment that is typed and it doesn't say, use some logic. And I'll certainly, if I haven't said where to round to, I'll give you a little bit of grace. But I do notice that sometimes people will still give me the 6 decimals. When you give me 6 decimals, I'm thinking, okay, are they thinking about the math? Are they thinking about the numbers they're putting in? Or are we just kind of blindly following along? All right, now we get to where we're solving equations with algebra. Now, for this section, we're going to be doing exactly the same thing. I'm going to give you 2 methods for solving these. Now, previous years, I've always given a whole bunch of equations with just letters and said rearrange the letters. And every year, students tell me, why do we just rearrange the letters when, if we're given a question, we always put the numbers in first and rearrange, which is typically true. And when we get to physics, we will definitely put the numbers in first and rearrange. Personally, I think it's the easiest way to do it. That's not to say we can't. But in the trades programs, we're not rearranging numbers and letters, or we're not rearranging letters just for the sake of being able to rearrange them. We're rearranging letters because we want to get to a final number. So I'm compromising this year. And I'm going to give you 2 methods. I do want you to be able to rearrange the letters. So I'm going to show you how to rearrange letters in at least one question. But most of the time, what we're going to do is we're going to put our numbers in and then we'll solve. And I think it's actually going to make things easier for us. This is going to tell me, do you really understand how to manipulate the numbers rather than just working with letters that don't mean a whole lot. So the equations that I've chosen are equations that you will see. This particular equation, B equals IR, or E equals IR, is an equation you will see in basic electrical. So voltage equals current times resistance. That's what they stand for. So if it sounds familiar, it may be if you've had some experience with that. So when we solve this one, we want to first thing what I'm going to do is I'm going to solve it just rearranging letters. So I'm going to call it method 1. I'm looking for I. So V equals IR. I'm looking for I. Sometimes underlining it can help you remember which letter it is you're looking for. Now here it's pretty simple because we only have 3 pieces. So it's I times R. So we know that in order to find I, we need to divide by R on both sides. That allows us to cancel the R out. And we have V over R equals I. Now that we know that, we can solve in our numbers. So we're going to place 120. So it says V equals 120. So where there's a V, we're going to write 120. Where there's an R, we're going to write 350. And then we're going to find what I is equal to. And I is equal to 0.343. Now I have kept 3 numbers because there's 3 numbers in each of these. So at least 2 decimal places or 3 decimal places would make sense. Depends on whether you want to count this 0 or not. We have 3 digits here, 3 digits here. So 3 digits in our answer typically is a good solution or a good way to get to roughly the correct accuracy. If we didn't keep any decimals, it would be 0, and that doesn't make sense. So that's method 1. Rearrange the letters first, then substitute the numbers in. Method 2 isn't going to make much difference for this question, but it could be easier for others. So method 2 says, well, we know what the equation is. Let's put the numbers in right at the beginning. So 120 goes in where the V is equal to I we're looking for. So we're going to leave that as I times 350. Now I have a habit of putting whatever numbers after a letter or whatever number I'm substituting in brackets. That's because sometimes we'll have times when we have a negative sign, and it's nice to keep it separate. It also helps us remember that that's one component. So it's just a habit I have. If you want to do I times 350, that works, but I do like using brackets myself. Now that we have this, we can see that, well, it's I times 350, so we're going to divide by 350. I would argue this seems like a lot less steps. So we still have 120 over 350. 120 over 350 gives us 0.343. Now, there will be times, I think, for electrical, where you will probably memorize these formulas. There's actually 3 ways we could rearrange this. V equals IR, we can solve it for V, we can solve it for I, or we can solve it for R. I'm not going to solve it for all 3 because I need to give you some equations to do later. You will also find the formula for power, which I know you're going to use. Power is voltage times current. So that's another equation that you'll see come into play, but it's going to be P equals V times I or E times I, depending on which letter you use for your voltage. And you will see that one come up as well, but exactly the same way of rearranging. So I won't show you a whole lot of examples with those particular ones, but I think once you put the numbers in, you'll see we've done that same kind of question before. Hopefully you found those questions quite straightforward. Now this is where things get a little bit trickier. So what I've done is I've pulled out the equations from our kinematics section in physics. So I'm kind of getting ahead a little bit. But when you start physics, I expect you to know how to rearrange them already. So we're going to practice rearranging them now rather than just working with any equation. So we're kind of prepping ourselves for December, or for January rather. So we've got an equation that hopefully you think looks slightly on the ugly side. We've got a square in it, we've got a fraction in it, we've got a little subscript here. It just kind of looks a little bit messy, but it's really quite an easy equation to work with. Now, this is an equation where if we wanted to solve it and use method 1 where you move all the letters first, it's a pain. It just looks messy, but it's a really good question to solve by putting numbers in first using method 2, plugging the numbers in, simplifying, and then figuring out what's the missing letter. And that's how typically we work with them in our physics course. So let's start with that method. So you'll notice here it says we're solving for V0. It's actually means V0. It's It's speed at the beginning of time, at the beginning of a period of time. So that V0 is one term. That's because there could be a V that's not a V0. Okay, so I've just left it so that when you see it again, it'll trigger your brain. You'll go, oh, I've seen this equation before, rather than changing the letters in it. But that's what that V0 is, just like having a single X. So those two belong together. You're not going to solve them separately. We have A is negative 9.8. Some of you might notice that is the speed due to acceleration due to gravity. T is 2.5 and D is 15.4. And we want to figure out this V, which is a speed. So to do this question, we're going to substitute all of our information in. So 15.4 is equal to this V with a little 0, we're going to leave separate, times T, which is 2.5. We'll notice we're not keeping any letters anymore. We're just putting the numbers where the letters belong, plus 1/2 times negative 9.8 times T squared, which is 2.5 squared. Now, when you look at this, we're going to simplify. So there's some things that we could do. Hopefully, if I just gave you this part of the question, you would be able to get that down to a single number for me. Well, it's connected to V0, but it's kind of on its own. We could multiply all of that together and get a single number. So that's where we should start. So the first step is to simplify. Okay. So 15.4, I can't do anything with that. V0 times 2.5, I can't do anything with that. It's still going to be a letter or a variable times a number. Plus, well, we can take all of this and get it into one number. Remember to follow order of operations. 2.5 squared should get done first. So 2.5 squared will leave you with 0.625 times negative 9.8 times 1/2 or a 0.5. Oftentimes people will write it in their calculator, 0.5 times negative 9.8. Now this negative sign in your calculator, you probably have a button that has that little negative, or it might have plus minus like that. That's the sign you want to use. Don't use your subtraction sign. So 0.5 times negative 9.8 times 2.5 and press your squared button. That's typically the easiest way to put it in. You can use your fraction button if you want, but we're going to want a decimal answer in this particular case. All right, so as we solve this, we get an answer of 30. It's actually a negative 30.625. All right. Hopefully you've got the same number. Take a minute, double check, make sure you're getting the same thing. If you're not getting the same thing, please send me an email. I hope I haven't made a mistake. Or double check that you haven't made a mistake as well. Sometimes it's just a matter of what to do with that negative sign. 1/2 is positive, 2.5 is positive. You're multiplying it by a negative, so you're going to end up with a negative when you're done. Okay? If you have one negative, you'll always end up with a negative answer. Some of those little things we assume you remember, but you may not. So the little things that you might brush up on. If you need a little refresh on that, don't hesitate to let me know. So now that we have that, before I keep writing, I'm going to do a little rearranging. I don't want to erase all the ink or I'll be in trouble. All right. So now we've got this. This is our term with V's. You'll notice this term has no letters and this one has no letters. So our like terms are on opposite sides of the equal sign. So we need to move this negative 30.625 to the other side. So in order to move a negative to the other side, we need to turn this piece into a 0. So let's balance it out with a positive. 30.625. I know this is adding here, but if I add another negative, it's going to get more negative. Think about the temperature. If it's cold and it gets colder, you add more cold, it just becomes more cold. If it's cold and we add in hot, eventually we should balance out. Come to either 0 degrees or to a positive number. So that's what we're looking at here. We've got a negative and we're balancing out the positive. On this side, 30.625. So this is now a 0. And now we have our new numbers. 15.54 plus 30.625 leaves us with 46.025. So 46 and 25 thousandths is equal to V naught times 2.5. This one can seem a little bit long. There's lots of rearranging to do. Now we're at a spot. This part of the equation should take you back to your ratio section. A letter times a number. Well, in order to get rid of that, we divide by the number. Divide both sides by 2.5. V naught is equal to, well, let me see. Where did I write it down? 18.4. I have 18.41 or 18.4. Now, why did I say or 18.4? Well, if we look through our numbers, 1 decimal, 1 decimal, 1 decimal, 1 decimal makes sense for our final answer. If you want to get picky on sig figs, you could say 2 digits, 2 digits, 3 digits. We'll go with the 2 digits because it's the least number of digits. Yes, you could argue that, and we could go down lower, but 18.4 typically would make sense. We don't need to keep any extra decimals than that. Again, I'm not being fussy about rounding. I'm just getting you to think about, do we need to keep a long, long, long string of decimals? Typically, if there's not all zeros in front of that decimal, we don't need to. All right, let's look at another physics equation. You're going to see some of these and you'll have to solve for some other variables. So if you're following along with me, you're probably smart. I hope so anyway. Hopefully you're not asleep or bored. I can't guarantee either of the above though. All right, so let's plug in our numbers in this question. Again, this is one that's easier to calculate if we plug the numbers in first to rearrange it. And that's typically what we'll end up doing. So we're going to put 3.4 in where D is. So 3.4 is equal to, so V naught is 1.5. So in our brackets, we have 1.5 plus V times T of 0.25, all divided by 2. So how do we rearrange it? Well, we have 2 on the bottom. We get a fraction. Nobody likes to keep fractions. Easiest way to get rid of the fraction? Let's multiply by 2. If we multiply both sides by 2, these 2's cancel out. So we've got rid of our fraction. 2 times 3.4 leaves us with 6.8 is equal to 1.5 plus B times 0.25. Keeping my brackets because I haven't got rid of this multiplying that's outside of the brackets, and we know order matters. Now I need to get rid of what's outside of the brackets before I can do this part. All right, so we're going to get rid of this multiplying. Well, that's easy enough to do. You know how to undo multiplying. We undo it with division, so 0.25. We're going to divide this side by 0.25. And 6.8 divided by 0.25 leaves us with 27.2 equals 1.5 plus V, and we'll subtract 1.5 from each side. And we end up with V is equal to 25.7. And again, you could argue if you wanted 26, I could go, you can argue your decimals a little bit, but I don't think we need to keep any more than that. All right, so it's not complicated, but it's just kind of thinking through the process. So when we have a fraction, and fractions can make things look ugly, get rid of the fraction first. Simplify whatever numbers we can. Once it looks more simple, get it down to just a letter times a number or a letter plus a number. We're going to do one more question. This is not a physics question. This actually comes from machinists. Now, I forget the exact details of this question. It is because it's not one that I use on a regular basis, but I do try to pull questions that come from trade books that you might see somewhere in the future, but this is one that would be more for machinists when they're creating a part. So this is for calculating tapers, large d is the big diameter, small d is a little diameter, and I believe L is the length over which it's tapered. But I don't have all the details on, but that's where this formula comes from. So I didn't just make it up. It's one that comes out of one of the trades books. It just might not necessarily match your particular situation. So for this question, we want to solve for L. You'll notice what I'm looking for is on the bottom. So this is one of those ones that people often make mistakes with. But let's start by substituting in our letters. So we're going to start with T. 0.6024 is equal to, big D is 1.74, minus little d, 1.475. You'll notice the decimal places are all over the place in this scenario. Whoever was measuring here did not use consistent precision, which probably isn't a good thing. But that's what happens sometimes when you make up numbers. So now that we have that, and then we'll divide by L. So we want to figure out what L is. The easiest way to solve this one, L is on the bottom. So let's get rid of the L. So when L is on the bottom, we're going to bring it to the top, which makes us move it to the other side, multiplying both sides by L. So L times 0.6024 is equal to 1.74 minus 1.475. Now let's combine what we can. Well, these two are easy to combine. So 1.74 minus 1.475 leaves us with 0.265. Over here, we still have L times 0.6024. So L times a number. To undo that, we're going to divide. These cancel out because they make a 1. Whatever you do to one side, we do to the other. And this is one where we're going to end up with a pile of decimals. And we need to think about where are we going to round to. So 4 decimals, so 3 decimals, 2 decimals, 4 decimals, 4 digits, and 3 digits. I would go, we need 3 or 4 numbers in our final answer. And I would probably say, well, 3 decimals kind of splits the difference between the two. So 3 decimals would make sense for us. So if you solve this one, we'll get L equals 0.4399. That's 4 decimals, and it keeps going. So if we want to round to 3 decimals, this 9 is going to push that 9 up. So we'll have 0.440 to show that we have rounded to cause that 0 to come in. And that gives us our final solution. So it's not overly difficult to rearrange these, but I find when you don't have X's in, the equations in their letter forms can look a little, I shouldn't say complicated, but they just don't look like what we normally would see. So sometimes because it doesn't look like what we normally would see, we can kind of panic on them and think, heck, I can't figure these out. But once you put the numbers in and you start condensing or simplifying what you can, they actually become much easier for us. So you're going to have a short assignment that has a few questions, which I'm going to have you solve. And I'm going to get you to solve them for some variables. So I want you to make sure you show your work, but you can use my examples as guides for how to show your work, but make sure if you turn off the lesson, you can still figure it out on your own because you are going to need to know how to do this algebra going forward. We're getting into the piece of the course where it's very algebra oriented. We may not be using your fractions as much, but we're going to have lots of algebra. We're going to see those conversions start to come back. So we need to make sure you can solve some of these basic algebra questions. This is as complicated as the algebra will get. So if you're feeling a little panicked, if you understand how to do these questions, you'll be fine. I've given you the most complicated versions you can get. Most of your algebra questions are ratio related questions or this kind of B equals IR questions. These questions, the physics questions, if you can do those ones, you've got the first section of physics figured out. You'll have no problem with that. Sometimes just pulling out the information is the tricky part. but we'll get a little bit of extra practice on these. We'll give you one extra lesson with solving some algebraic questions, just more of a review, and then we'll be into our trig section.